Hello everyone, I'm Jivika Kancherla and I'll be explaining you guys the solving of question 1 in homework 6 of the course Probability and Stochastic Processes. Now let's have a look at question 1. It is given that x and y have joint density function where the probability density function of x comma y is equal to 1 plus xy by a for x less than 1 and mod y less than 1. Otherwise, the probability density function will be equal to 0. Now we're supposed to calculate 5 parts in this question. In the first part, we are supposed to find a, so that the above defined is a valid joint density function. Now let's look at the solving for this question. Given x and y are joint density functions and f of x comma y is equal to 1 plus xy by a for mod x less than 1 and mod y less than 1, 0 otherwise. Now in the first part we're supposed to calculate a. Now we know that the valid density function, that is integral from minus 1 to 1 f of xy dx dy is equal to 1. Since we know the f of x comma y is equal to 1 plus xy by a, let's substitute that here, and upon doing the integration we will get the value of a is equal to 4. In the second part, we are supposed to calculate if x comma y are uncorrelated. Now let's check. Therefore, to check, we will be calculating the expected value of x comma y. That is, expected of x comma y is equal to integral minus infinity to infinity x comma y f of xy dx dy. Now we know the f of x comma y value as 1 plus xy by a. We will substitute that in this equation. Now from a, we know that the value of a is equal to 4. We solved it here. We will substitute that here, and we will get that the integral from minus 1 to 1 xy plus x square y square by 4 dx dy. Upon solving this and simplifying it, we will get that integral from minus 1 to 1 2 into y square by 12 dy, which is equal to y cube by 18 from minus 1 to 1, which the value will be equal to 1 by 9. Now let's calculate the expected value of x, which is equal to integral from minus 1 to 1 x plus 1 plus xy by a into dx dy. Now if we calculate this by solving for the integral, we will get that expected value of x is equal to 0. Similarly, by taking the function for expected of y, we will get its value is equal to 0 as well. Now since the expected of x comma y is not equal to expected of x into expected of y, therefore they are not uncorrelated. Now in the third part, we are supposed to calculate, check if x comma y are independent. In the second part, we calculated and we proved that x comma y are not uncorrelated. Therefore, since they are not uncorrelated, they are not independent as well. In the fourth part, we are supposed to find the joint density function of x square and y square. Therefore, let us assume that x square is equal to u and y square is equal to v. Now, this will have 4 roots. Therefore, the probability density function of u comma v will be equal to the probability density function of root u root v plus the probability density function of minus root u root v plus probability density function of root u minus root v plus probability density function of minus root u minus root v by mod j. Now let's calculate mod j value, which is equal to the matrix form will be 2x 0 0 2y. By calculating the determinant, it is equal to 4xy. Now we know x is equal to root u, y is equal to root v, which is equal to 4 into root u into root v. Now the probability density function for u comma v will be equal to 1 by 4 into root u root v into 1 by a plus all of this. Now as the root u and root v value will cancel, we will get the sum is equal to 4. Therefore, the value of f of u comma v is equal to 1 by 2 root u into 1 by 2 root v. Therefore, f of u comma v is equal to 1 by 2 root u into 1 by 2 root v for u between 0 and 1, and for v between 0 and 1, and the value will be 0 otherwise. And f of u is equal to 1 by 2 root v if the value of u is between 0 and 1, and otherwise the value will be 0. And f of v will also be equal to 1 by 2 root v if the value of b ranges from 0 and 1, otherwise the value will be 0. In the fifth part, we are supposed to prove or disprove that x square and y square are independent. Since we know that f of x comma y is equal to f of x into f of y, which means they are independent. Therefore, x square and y square will also be independent.